Imagine walking into a doctor's office in the middle of the 19th century with a sharp pain in your leg that you just cannot explain. The room might smell of wood smoke and old leather, and the man standing before you would likely be wearing a formal frock coat rather than a white lab gown. Back then, your doctor would have very few tools at his disposal to figure out what was happening underneath your skin. He might poke and prod the area with his fingers, listening to the sounds of your joints, or asking you to describe the sensation in painstaking detail. He might use a wooden stethoscope to listen to your breathing or the rhythm of your heart, but ultimately, the skin was an impenetrable barrier that guarded the secrets of your internal anatomy. If you had a broken bone that had not pierced the surface, or a piece of metal lodged deep in a muscle from an old injury, the only way for a physician to truly see it was to cut you open. This was a time when surgery was a last resort, a desperate and terrifying gamble, often performed in environments that were far from sterile and without the benefit of modern anesthesia. The human body was essentially a black box, a container of mysteries, and for centuries we had been trying to understand its inner workings by looking at it from the outside in, guessing at the shapes and movements hidden beneath the surface. This was the hard constraint of medicine for thousands of years. We were experts at the surface of things, understanding the texture of the skin and the color of the eyes, but the interior was a land of shadows and speculation. Doctors were essentially guessing, using their years of experience and intuition to piece together a puzzle they could not actually see. This led to countless misdiagnoses and treatments that were sometimes worse than the ailments they were meant to fix, as surgeons often had to explore the body through trial and error. The world was waiting for a light that could shine through us, a way to turn the solid wall of the human body into a clear window. We had mapped the vast reaches of the oceans and tracked the movements of the stars in the night sky, but the 2 inches of flesh beneath our own skin remained a complete and total mystery. It was a limitation that seemed as permanent as the mountains, a boundary that science could describe but never cross. Then, as the 19th century was drawing to a close, a breakthrough happened in a way that no one really expected. It did not come from a prestigious medical school or a busy urban hospital, but from a quiet physics laboratory filled with strange glass tubes and humming electrical coils. A researcher was experimenting with high-voltage electricity, trying to understand the strange, ghostly glow that appeared inside vacuum tubes when power was applied to them. He was interested in the fundamental properties of light and energy, not in medicine. He had covered his lab in thick black cardboard to keep the room totally dark so he could observe the faint emissions from his equipment. Yet he noticed something that seemed impossible. A small screen coated in a special chemical, sitting several feet away from his experiment on a different table, began to glow with a faint green light. He was baffled by this observation. There was no visible light coming from his tube because it was completely shielded by the cardboard, and yet the screen was clearly reacting to something in the room. He began to move various objects between the tube and the screen to see if he could block whatever invisible force was causing the glow. He tried a book, then a thick piece of wood, then a sheet of metal. Most objects allowed this invisible energy to pass right through them, as if they were made of nothing at all. But when he held his own hand in front of the screen, he saw something that must have felt like a beautiful dream or a terrifying nightmare. He saw the dark, sharp shadows of his own bones, surrounded by a faint, ghostly outline of his flesh. He was looking at his own skeleton while he was still alive and breathing. It was the first time a human being had ever seen the framework of their own body without the use of a knife. This single moment changed the course of human history. It was the birth of what we now call the X-ray, though at the time, the discoverer used that name simply because X is the mathematical symbol for an unknown quantity. He did not know what these rays were or how they worked, but he knew they had the power to reveal the unseen and bypass the barriers of physical matter. He spent weeks in his lab, eating and sleeping there in a state of intense focus, capturing the first ever images of the internal human structure on photographic plates. When the first image of a human hand was published, showing a wedding ring floating around a skeletal finger as if suspended in air, the world went into a frenzy of excitement and disbelief. It is hard to overstate how quickly this technology moved from a laboratory curiosity to a global phenomenon. Within months, people were talking about these rays in every major city on the planet. It was not just doctors who were interested in the discovery. The public was absolutely fascinated by the idea of seeing through things. It felt like science fiction had become a sudden reality. Some people were terrified by the implications, believing that these rays would allow strangers to see through their clothes on the street or peer into their private homes through brick walls. There were even companies that tried to capitalize on this fear by selling lead-lined underwear to protect the modesty of the public from the prying eyes of anyone with a machine. It was a strange and often humorous mix of genuine scientific wonder and Victorian-era panic. But while the public was busy with fantasies and fears, the medical community was moving fast to integrate this tool. Surgeons realized that they finally had a map to guide their work. No longer would they have to search blindly for a bullet or a needle hidden in a patient's limb, causing unnecessary trauma to the tissue. They could see exactly where the object was and plan their surgical path with precision before the first cut was even made. This made procedures faster, safer, and far more successful than they had ever been in the history of medicine. In the early days, these machines were huge, clunky, and often temperamental. They required massive amounts of power and could take several minutes of continuous exposure to get a clear image on a plate. Patients had to sit perfectly still for long periods, often while the machine buzzed loudly and filled the room with the sharp smell of ozone from the high-voltage sparks dancing in the tubes. As the technology began to scale, an entirely new industry was born. Factories started churning out specialized glass tubes and the chemical coatings needed to develop the images. Standards began to emerge for how to take these pictures and how to read them accurately. This was the era where the specialist, known as a radiologist, first appeared as a distinct profession. It was not enough to just own the machine. You needed someone who understood the nuances of anatomy well enough to interpret the many shades of gray and white on a piece of film. Economics played a huge role in the spread of this technology as well. At first, only the wealthiest hospitals in major cities could afford such a luxury. But as manufacturing methods improved and the machines became more reliable and portable, they started appearing in smaller clinics and even on the front lines of distant wars. The impact on the battlefield was perhaps one of the most significant early applications of the technology. During conflicts at the turn of the century, portable units were brought to the front lines, often powered by small gasoline engines. For the first time, military surgeons could quickly assess a wounded soldier and decide which cases were treatable and which required immediate attention. It saved thousands of lives by streamlining the chaotic and often overwhelmed process of field medicine. Back in the civilian world, the technology was being used for everything from finding swallowed coins in children to checking the fit of new shoes. For a few decades, you could walk into a high-end shoe store and stick your feet into a wooden cabinet to see how your toe bones lined up with the leather of the shoe. It was considered the height of modern convenience and a fascinating way to entertain children while their parents shopped, though we now know the risks of such casual use. However, this rapid adoption came with a dark side that took time to understand. In the early years, no one knew that these invisible rays could be dangerous to living tissue. The researchers and doctors who worked with them every day did not use any form of protection. They would often use their own hands to calibrate the machines, checking the sharpness of the image by looking at their own bones over and over again. Eventually, these pioneers began to notice strange burns on their skin that would not heal, looking like severe sunburns that went deep into the flesh. Some lost fingers to the damage, and others developed more serious and systemic illnesses. It was a tragic realization that this tool of healing could also be a tool of harm if not handled with extreme care. This led to a second wave of innovation focused entirely on safety and protection. Engineers developed heavy lead shields to block the rays from hitting the parts of the body that did not need to be imaged. They created more sensitive film and better tubes that required less exposure time, meaning both the patient and the doctor were exposed to far less radiation during a procedure. This transition from a wild and unregulated discovery to a disciplined medical practice is what allowed these rays to become a permanent and trusted part of our lives. It forced the scientific community to develop standards for safety that we still use in almost every branch of medicine today. By the time we moved into the middle of the 20th century, the foundation laid by those first glowing screens in a dark lab had expanded into an entire universe of medical imaging. We moved beyond simple shadows of bones. We learned how to use different types of energy and different perspectives to see not just the hard structures of the body, but the soft organs, the flowing blood vessels, and even the electrical activity of the brain. The original discovery was the spark that lit the way for more complex systems like the CT scan, the MRI, and the ultrasound. It fundamentally shifted our relationship with our own bodies. We no longer had to wonder or guess what was happening inside us. We could see it in high definition and plan our health with a level of certainty that was previously unimaginable. The ripple effects of this transparency changed almost everything about society. It changed how we teach medicine, because students could study living anatomy in real time instead of just relying on the study of cadavers. It changed the insurance industry and the legal system, as physical proof of an injury could now be captured on film and presented as undeniable evidence. It even changed our culture, giving us a new visual language for the interior of the human experience. The skeleton, which had once been a symbol of death and decay, became a symbol of life and a tool for the preservation of health. Today, it is almost impossible to imagine a world without this ability. We use it to catch diseases in their earliest stages, to guide robotic surgeons through delicate procedures that require millimeter precision, and to ensure that every broken bone is set perfectly. It is a technology that has become so ubiquitous that we often forget how miraculous it truly is. We have achieved a kind of transparency that our ancestors would have considered divine or impossible. The barrier of the skin has been bypassed, and in doing so, we have saved more lives than we can count. We live in an era where the black box of the human body has finally been opened for the benefit of all. But this leap forward in medicine was happening at the same time as other massive shifts in how we organized our world. While doctors were learning to see through the body, other innovators were figuring out how to connect the world in ways that were just as invisible and just as powerful. To understand how our modern life really came together, we have to look at how we started talking to each other across vast distances and the systems that had to fail before they could succeed. And that is how X-rays and medical imaging set the stage for the era of diagnostics we live in today. In the next episode, we will take a quick step sideways in our story to explore the telephone and switching networks. This is the missing context that explains how a world of isolated discoveries became a truly global network. If you enjoyed this journey into the unseen, make sure to subscribe so you do not miss our next chapter.